A very good morning to all of you. This is Kundan. Today we are going to discuss on brain cognition and EEG data analysis. Actually, I have done some practices and I will share my experience on data analysis part of EEG. So, before we will familiar about EEG, we must have to know about human brain. Human brain is most complicated structural body, which composed of billions of neurons. Actually, these neurons are the source of information, and our brain is divided into different structures called lobes: the frontal lobe, the parietal lobe, the occipital lobe, and the temporal lobe. The frontal lobe is mainly involved in complex thinking, planning, organizing, problem solving, short-term memory, etc. And our parietal lobe mainly engaged with feelings, gathering sensory information. Sensory informations like temperature, texture, taste. These all are sensory information. Our occipital lobe captures images from eye and sends it to brain. And it's also helps to convert it in form of memory. So our temporal lobe gives us sense of smell, taste, and sound. Apart from these, our brain emits electrical signals of 0.1 hertz to 100 hertz. 0.1 hertz to 100 hertz. Most frequentile waves are gamma waves, 25 to 60 hertz, beta waves, 13 to 25 hertz. These waves are engaged in high stage vigilance and cognitive activities. Gamma and beta are engaged in high stage vigilance and cognitive activities. Theta waves are 4 to 8 hertz. Delta waves ranging from 1 to 4 hertz. These theta and delta mainly play a role in drowsiness, sleep, and condition of rest, etc. Apart from this, one more wave is alpha wave, which is from 8 to 13 hertz, and it is responsible to give relaxed wakefulness in adult humans. So these are the basic things that we know about human brain. Next one is EEG. Electroencephalogram is the signal captured from the brain. In short form, it is called EEG. And cognition means what, why, and how we are doing with our brain. Means gathering knowledge and information from brain is cognition. Next part is EEG signal analysis. In EEG signal analysis, first we will acquire the data by the means of data acquisition systems or EEG devices. EEG devices may be wired or wireless devices. So the signal may be classified in alpha, beta, gamma, theta depending on the devices, or you may get a single signal and you have to classify the signal in different waves: alpha, beta, gamma, theta, delta. You have to classify by means of programming tools. Another step is preprocessing. Preprocessing mainly involved of removal of artifacts. Actually, artifacts are noise. Like EEG came with some motion artifacts, some ocular artifacts, cardiac and muscles movement artifacts. So these artifacts will be removed before the feature extraction stage, and this is a very important to remove the artifact from the original signal. Also, another one step is preprocessing is normalization. You must have to normalize the signal, and there are so many steps are involved in preprocessing. Also, the next step is feature extraction. What feature you want to get to collect from your acquired EEG wave, like power expected density, root mean square velocity, and root mean square, and all. In the next step, you have to classify the features for your purpose. So the next one is various analysis methods. There are so many analysis methods are used for EEG data. The very basic method is Fourier analysis, orthogonal polynomials. Some standard methods are wavelets, blind source separation, independent component analysis, Hilbert-Hung transform, topological data analysis, means data analysis by means of topology, classical and Bayesian statics, generalized linear and additive models, functional data analysis, machine learning, deep learning. Apart from these, some AI methods are also common feature nowadays. So these are the very basic methods and to use for data analysis. First one is Fourier analysis. Fourier analysis is most oldest tool, and it is based on Fourier transform. Fourier transform, it's composed of cosine and sine waves of definite frequencies. So Fourier based domain we use EEG signal analysis. Next one is wavelets. Wavelets are the standards forms to analyze EEG signals. Actually, the time localization is the main problem in EEG signal analysis, and sin x and cos x are not localized in time domain. So to localize our EEG signal in time domain, we use wavelet. Few types of wavelets are continuous wavelet transform and discrete wavelet transform. There are so many wavelets are developed by the different scientists like Gaussian wavelets, Gabor wavelets, Morlet wavelets, Poisson wavelet, Mexican hat wavelet, Shannon wavelet. Next one is blind source separation and independent component analysis. So blind source separation means BSS. BSS is based on array method. The signal is turned into array form and then after analyzed. And in independent component analysis, it assumes that original sources are statistically independent. And we use several algorithms of ICA like InfoMax, maximum likelihood estimation, fast ICA to calculate our features. Classical and Bayesian statistics. Classical statistics is the mean standard deviation and average values of signals can be calculated using classical statistics. Mainly we acquire hypothesis testing, p-value, f-value, confidence intervals. These kinds of things are calculated by classical statistics. Analysis of variance. ANOVA is one of the best method to take information, chi-square test. So these tests are related to classical statistics. Also Bayesian statistics is also applied to compute the parameter probabilities. Another tool is functional data analysis. In functional data analysis, it is a continuous data method, and data is smooth in this method, and PCA, principal component analysis, is central concept. Another method is machine learning. Machine learning is a very new concept, and mainly it came from artificial neural networks, and it based on the fundamental principle of data acquiring, abstraction, generalization, and evaluation. Feature extraction is a very important part of EEG data analysis. What features we want to gather from EEG? These are divided into two parts, fundamental and derived. The fundamental features are root mean square, power spectral density, energy, entropy, and all. So the derived means those features which depends on fundamental features. So there are some examples of derived quantities as frequency weighted energy. Actually it's depend on energy of frequency. Engagement index. There are so many engagement index are developed which depends on alpha, beta, gamma, and theta, and there are so many engagement index formulas are developed. So these are derived. There are two types of classification techniques. One is linear and another one is non-linear classification. In linear classification, you can see that easily the data is classified in two types. Data is simply classified in two types. In non-linear classifiers, the data is in separable form. In non-linear classifier, you can see that the data is in between the another data. One kind of data is holding the another data, and another form is inseparable, where both kind of data are merged. Some useful tools to analyze EEG signal are MATLAB or Python, Octave, Weka, EEG-seq. So frequently I used MATLAB and Python. Nowadays, so many AI softwares are came in feature also. Few challenges in EEG data analysis are inverse problem. Actually, inverse problem is related to source localization. You have to finding a S signal given from a known X signal. S is unknown and X is known. So this is the very basic problem, inverse problem. Second one is understanding brain function. Understanding brain function, how its cognitive activities, motor action, and all. Data analysis accuracy, how much accurate is your data analysis pattern? What pattern is good for data analysis and what is not good for data analysis? What practice must be done and what is not to be done? And there are so many developmental ideas also. So nowadays it's very challenging to acquire human cognition level and to acquire information from EEG is a challenging role. So we are developing the technology day by day, frequent and good, to gather information from EEG signal in both clinical and non-clinical cases. We may design some dedicated algorithm, we may design some dedicated machines to acquire information. Thank you. If you have any questions or feedback, kindly write me on my email address, contactus.urg@gmail.com. Thank you.